And here we go. So what did we do yesterday? We talked about graphs. I reminded you of the magic number, 3.6. Just going to make that a wee bit bigger, I think. We talked about dependent and independent variables, and you'll remember that independent variables go where? Independent. Go on the bottom, the x. Dependent goes on the y. Very good. And we looked at this graph right here of braking distances. We talked about how to plot graphs, right, which I think everyone should be pretty comfortable doing. I reminded you should not connect the dots. You should draw a line or curve of best fit. We talked a bit about the different relationships, linear relationships, obviously straight line graph. We talked about y equals mx plus b, where m is the slope and b is the y-intercept, right? Y-intercept. But what does the y-intercept mean? Your voice is changing.
It's where the line crosses the y-axis.
The y-axis. And x is equal to? 0. Good. Okay. I reminded you how to find slope, rise over run. We talked about how the slope itself is a property or has some meaning for the system. In the one example, it was the reaction time, right? And I showed you how the units sort of work out kind of thing. We talked briefly about negative slope, down to the right. We talked about quadratic relationships. We went through a big thing there where I showed you that if you double your speed, what happens to the distance? 4 times, triple the speed. 9 times, remember that? Okay. We talked briefly about inverse relationships. I thought of a good inverse relationship this morning. It was the more you talk in class, the less you learn. Inverse relationship. No? Maybe it's not the best one. And then we got into the concept review, and I don't think we got too far with these answers. Am I right? Okay, so should I give you like 5 minutes to work on these? Or how did we? I started giving you answers, right? Not at all? Okay, how about I give you the answers for the first 2, and then I'll give you a couple seconds to try 3 and 4, and then we'll go through them. Okay, so let's do that. Let's have a look at number 1. I'll give you a second. All right, so suppose a student doing a lab determined that the y-intercept for a graph reaction distance versus speed was 3.4. What would this mean in real life? Is it possible? Draw a sketch of what this would look like. So I think I drew the sketch yesterday, did I not? Would it not look like that? Right? Okay, it's got a y-intercept of, say, 3.4. And again, this is reaction distance versus speed. So what does it mean? Well, it means that if your speed is 0, you still need a distance of 3.4 meters, which doesn't make a lot of sense, does it? If you're stopped, you don't need any distance to stop, right? So is it possible? Not possible. What would it mean? It means someone screwed up. It's not possible. Not possible. Number 2, in the earlier braking example, at what speed is the reaction distance 10 meters? In other words, go back to this graph here and find a reaction distance of 10 meters. And did I get this far? I don't remember. It would be about there, would it not? Right? That line there is the reaction distance line. 10 meters is about halfway, so about 14 and a half meters per second, something like that. Right? So about 14 to 14 and a half meters per second. All right, so I don't think we got past 3 and 4, did we? Okay, so I'm going to give you about 4 or 5 minutes there, and you guys do 3 and 4 with the person sitting beside you, and then I'll give you an answer right away. Alrighty, let's look at number 3. Number 3 says a graph of reaction distance versus speed is made, and the slope is found to be 0.74. I'm just going to draw a picture down here if I can. Okay, so I've got a slope of 0.74. Matt sounds like he wants to say something, so I'm going to ask him, suppose that another experiment is made and the slope is found to be steeper. They're going faster. So, Matt, give me a value for the slope of the blue line. A possible value. There's lots of different possibilities. Just anyone.
It's supposed to be bigger than 7 point.
Well, it says the slope is found to be steeper.
Like bigger or smaller?
I'm asking you. Yes, you do. You're being lazy.
I actually don't know.
Then think.
Okay.
I'm going to come back to you. Go ahead and go. Pardon me?
Smaller.
Smaller. Fantasy, right?
Exactly.
Pay attention, you guys. Mary, is he right? He says smaller. Is that right? Why not?
Because for it to be steep, it has to be bigger.
Bigger slope, right? Give me an example of a number that would be good in that sense.
Like 9.5.
Okay, 0.95 sounds perfectly all right. You understand why, Miguel? We're talking about the slope. We're talking about the slope. Suppose another experiment is made and the slope is found to be steeper. Steeper, right? Okay. So, what does that mean about the reaction time, Mary?
It means that it takes a longer to react to this larger reaction time.
Use the word slower or faster for me.
Slower reaction time?
You're going faster.
Put the phone away and think about it.
That's what I said.
Okay. Slower reaction time?
No, I said faster.
Faster reaction time.
Because the
Slower reaction time?
It's slower because it's bigger. So you have.
going faster.
What's your stopping distance?
Okay, well, we'll come back to that for a second. Regan said you're going faster. Is that true?
Yeah.
Is that true, Tony? Don't know? All right, let's just back up here. Okay, if you haven't been paying attention, it's now time to, because I might call on you, right?
But I'm so tired.
A graph of reaction distance versus speed. So how many different speeds are we talking about?
One.
Lots of different speeds.
Oh, wow.
10 meters a second, 15 meters a second, right? This is a graph of reaction distance versus speed, and the slope refers to the reaction time.
So it's reaction
So-
time is longer than your faster. No,
Your stopping distance is longer. Is that what I was trying to say? Okay, so now back to my question is, I'm with Mary on this one. The slope is about 0.95. Does that mean faster or slower reaction time?
slower. Just saying.
Okay, I'm going to give you about 10 seconds, and you're going to have to put your hand up whether you're on the slower reaction time side or you're on the faster reaction time side, and you're not allowed to abstain. You have to vote.
Being different.
Ready? Mary has made an argument, I think, right?
I'm thinking that, well,
Being
are
different.
you going faster? I'm thinking like driving. You're going faster.
Are you going any faster?
No.
Many, many different speeds. We're talking about the reaction time, not the speed of the car. Okay, okay. Listen up.
From your brain to send a message, you
Yeah.
have to be fast because you're seeing it quicker.
Okay, time's up. The slope of the new person is 0.95. The reaction time of the new person is 0.95. How many people say that's a slower reaction time?
Oh, yes.
How many people say that's a faster reaction time? Good, because it's slower. Right? You're absolutely right. You said it right, right? If it's the time is longer, it takes longer, 0.95 seconds, right, to get there slower. If I go out and run the 100 meters at 12 seconds and Kish runs it in 27, I'm faster, right? But it's because the distance is the same. In this case here, right, it takes longer, right? It takes longer. The bigger number is 0.95 not longer, right? Right? So it's slower. A bigger time means a slower reaction time. You said it better than I did. Slower reaction time is what it means. Hey, that's a really good question. Oh, test question. Number 4. This graph right here shows the relationship between the circumference and the diameter of a circle. Would a different circle circumference create a different graph? And what does it mean in the slope? And what are the units of the slope? Okay. Tell me, Tristan, what is the circumference of a circle? What's the definition of circumference of a circle? Distance all the way around, right? Okay, and what's diameter? Okay, good. So let's just quickly, I'll just draw that, right? Circumference is all the way around. Diameter is distance across, right? Okay, so this says, it shows a relationship between the circumference and the diameter of a circle. Would a different circle circumference create a different graph? Casey. Would a different circle create a different graph?
No.
That sounded like a yes.
Can I guess?
That sounded like a yes. Would a different circle create a different graph?
Still a circle.
So you're saying that a different circle would create a different graph? Right?
It's the same graph. Maybe it's the same size circle.
Okay, I'll fair enough. Would a different sized circle create a different graph?
No, it wouldn't.
No, would it?
No, it wouldn't.
No, because either way
It would? I'm throwing you some curveballs here today. Okay, these guys got here. Then how many, or I'll ask Miguel. Miguel, how many circles are shown in that graph? 6? Well, certainly 5, right? There are certainly 5 circles shown. There's one with a diameter of 1, one with a 2, one with a 3, one with a 4, one with a 5, and in fact, all the ones in between. How many circles are shown in that graph? An infinite number of circles. So would a different circle not just fit right on that graph? Would not a 3.5 diameter circle be on that graph already? The only circles that aren't on that graph are ones that are bigger than 5. And what would be the same about one that's bigger than 5 then? What would be the same if I had a graph with if I had a circle with a diameter of 6? What would be different here? It would just be farther out on the circle, out on this, right? Okay, so yes, the slope would remain exactly the same. The slope would remain the same. What is the meaning of the slope? Now this one's even harder. What's the formula for circumference and diameter of a circle? Like if I put circumference and diameter like that, what do I need to make this into an equation? Pi times diameter. Right? Pi times diameter? Yes? Right? Okay. Now, if I look at this graph here, what's the y quantity? What am I measuring on the y? What am I measuring on the x? Okay. So in other words, my slope from the graph is circumference divided by diameter, right? Right? Okay. M is slope, right? How do I turn this equation into circumference divided by, or circumference over diameter? I would do what? I would do that, and then what would happen? And then what would the slope equal? Oh, the slope is equal to pi. In fact, if I actually went and looked at this graph here and calculated the slope, what number would I get? 3.14, 15926.
5.
Does 5 come after that? The slope of this is 3.14. Okay? So what's the meaning of the slope in this case? It's pi. Right? Every slope has a meaning. What would be the units?
Centimeters.
Divided by?
Centimeters.
Which is?
Centimeters.
Nothing. No units. Centimeters divided by centimeters cancel. Does pi have units? Like, is it 3.14 centimeters? No, it's just 3.14. It's just a number. Okay, just a number. So the units of the slope would be nothing. All right, that's a lot of stuff going on in your head. Here's what I'm going to do. I'm going to give you a chance to work on number 1. Number 1 is simple. It's just, can you read a graph?
No.
Okay. In 5 minutes, I will give you the answers, and then we will move on to number 2. Okay? So you got 5 minutes to work on number 1. Go. Let's have a look at number 1, because it does cause some discomfort for some people.
Yes.
The graph shows the mass of 3 substances for volumes between 0 and 60. What is the mass of 30 cubic centimeters of each substance? So what that means is go over to 30, right there, and go up, right? I don't think so. So you should have got something like about, what's that, about 55 or so?
We got 60.
Okay, anywhere close there. 55 is good, 55, 60. The next one would be about 95. And the next one is, looks like it's 150, right? Can you read a graph?
Yeah, but it's not.
If you had 100 grams of each one, what would their volumes be? So here now you go across, right? 100 would be 20, and then it looks like about 33 or so. And then the next one would be 50, right? 20, yeah.
20 is for the trolley.
Yeah. Okay, those are easy. C is the harder one. What are the units of the slope of the graph? The slope is the y, Robert, divided by the x. So what are the
Grams divided by centimeters.
y units? Grams. What are the x units?
Centimeter cubed.
Centimeters cubed. So the units of the slope are grams per cubic centimeter. What do we measure in grams per cubic centimeter? That's cubic centimeters. Does anyone know what you measure in grams per cubic centimeter? I'll give you a hint.
Is it gas?
It could be. I'll give you a hint. It starts, the formula is D equals M over V.
Density.
Density is the correct answer.
Oh, so I was right.
I did not know that. I went there.
The density is measured in grams per cubic centimeter. How much does it weigh per volume? Okay? Density is the meaning of the slope. All right. 5 minutes for number 2. Go. Can I safely assume that you went 10, 20, 30, 40, 50 across the bottom?
Yeah.
And I'm hoping you went 5, 10, 15, 20, and so on the side. Okay. All right. And when you plot them, you should get something along the lines of this. 10 and 7.9 is about there. 20 and 15.8 is about there. 30 and 23.7.
This is number 2.
Number 2, is it not? 40 and 31.6. And 50 and almost 40, right? Then you draw a line. Should it go through 0, 0?
Yeah.
It should, right? How come it should?
Because at 0, the density and the gas.
No, the density is the same. At 0, the mass, like 0 grams, should have 0 volume, right? And vice versa. But the density remains the
Where
same.
do you put the dependent variable?
Dependent is on the y. We've been through that.
I have a question.
Okay. Yeah.
That's really related to this. What if it's like helium? Would the mass be negative then?
No, helium has a mass. It's just less than air, that's all. Yeah, that's why it floats, right? Because air has a mass too.
Helium has a mass, a molar mass of 1.01.
Oh. Okay, so now there's my line of best fit. B, describe the resulting curve. Miguel got all fired up because he said it's not a curve, but a line is simply a straight curve. So your answer for B would be it's a line. Okay, and now how do we find the equation? Here's the hard part. Watch carefully because I'm going to describe how to find the equation. You pick 2 points. I like that one and that one. Can I pick any 2 I want? Absolutely, I can pick any 2 I want. Now I'm going to write m is equal to, what's my slope? Well, the y-coordinate here is 39.6. I subtract the y-coordinate down here, which is 7.9, over my x-coordinates, which are 50 minus 10. And I get
31.7.
Thanks, Ben. 31.7, I guess I could have done that in my head, divided by 40. And what is the answer?
But is that be the
0.79.
0.79? Sounds pretty familiar. 0.79. 0.79 is the slope. What should the y-intercept be? Should be 0. How do we actually figure it out, just in case it's not? Let's just do this. We're going to write y equals mx plus b. I'm going to write a slope of 0.79. Do I know a y and an x? I sure do. In fact, I'm going to use the first one. The x is 10. The y that goes with 10 is 7.9. Solve for b. What's 0.79 times 10? And so what's my b value equal to? Should it not be 0?
Yeah.
What if I got 0.1? Would that be okay? Absolutely, it's okay, right? It should be 0, but 0.1 is okay because it's science and things don't work out perfectly, right? So what is my equation? My equation then is y equals mx plus b, or y is equal to 0.79x. Do I need to write the plus 0?
No.
Not really. Should I replace the y and the x with mass and volume? Sure you can. The y is our mass equals 0.79 times the volume. And if you want, you could write m is equal to 0.79b if you really want. Now I know there's not a lot of time left, but I would really like it if you guys could get number 3 done for tomorrow. Okay? Use what I just showed you. Did I not do B? Oh, what's D? Oh, doesn't it say what's the units of the slope of the graph? All that again is, once again, grams per cubic centimeter density, right? You guys can stay where you are. Stay where you are. Stay where you are. Bell's going to go. Stay where you are. Work with your partner. Do number 3. I don't care. Work on number 3. You'll have a new partner tomorrow.